All right. Speaking about who we are, as I mentioned before, I am Violeta. I'm a digital adoption manager for life events in EMEA. I'm based in Bucharest. And today I'm joined by Marta and Mika, who will be your presenters for the OCI Service Mesh session. They will tell you more about themselves shortly. Keep in mind that everything we show today is for educational reasons. So in case you would like to use our services further, you may connect with somebody from the Oracle account team. Also, keep in mind that our services are enhanced regularly. So you might find some differences within the menu if you're watching any of our recordings in the future. That was all on my side. I would like to pass over to Marta now. Marta, the floor is yours.
Perfect. Let me share my screen real quick.
Sure.
Thank you, Violeta, and welcome everybody to the session about the Service Mesh. My name is Marta Tolosa. I'm a cloud native application development specialist, and everything that my team does together with my colleague Mika is everything related to cloud native application development, of course, Kubernetes, DevOps, serverless, all this nice stuff. Today we're going to focus a little bit on the Service Mesh, but also on the other products. We have two demos planned. The first one is already deployed. We'll go through it a little bit, and then we'll kick off the second one. And during that time, we will have a couple of slides. It's not marketing slides, don't worry about it. It's just to explain a little bit the concept of the Service Mesh and why do we think it's important. This is the architecture of the first demo. It's a Node.js microservice that is deployed in Kubernetes. It serves a static HTML page. It's running on port 3000. It's a Bootstrap example, and you can reach it through the load balancer. Additionally, we have also deployed Grafana to check on the traffic. We have set up that 100% of the traffic goes to this service, to the Node.js service. Okay, we will show this in the screen right now, and then the second demo, it's a little bit more complicated, a little busier, these slides. It's a dynamic microservice. So everything will start in the DevOps service. We have a Git repository there. Mika will change a little bit the code to a commit, and that will trigger that the pipeline starts. The goal is to have a traffic split. And for that, we're going to use the Service Mesh. So we have the same service, version 1 of the service and version 2 of the service, both running on port 3000. The version 1, however, returns a web page that is dynamic this time, okay? And this web page retrieves the information from another microservice. It's called Price. It's a new microservice, and this microservice gets the price itself, the data and information from an autonomous database using a Node.js Oracle library. Okay, this price service is not exposed externally. The home is through the load balancer, but this one is only accessible internally. The autonomous database has also been deployed through the pipeline using kubectl, and of course the Oracle Service Operator for Kubernetes. Additionally, we have created a new, like a kind of back office application, a mini application that is in Apex. And with this application, you can update the prices. So it's like a mini admin, and this itself can also be updated in pipeline using Liquibase from Git. And at the end, like originally, we'll see the traffic split via Grafana. I hope it wasn't too confusing to build. Let's go for it.
Yeah, thanks, Marta. I'm gonna do that. So yeah, we already had an error on the previous slide because the traffic split is 80-20, not 50-50. Yeah, but no problem. So I will share my screen. Okay. Let's not worry about that too much. So Mika, yes, nice to meet you all. So let me try to do the stuff that Marta spoke about. So first of all, yeah. We have this project in DevOps. So there's the Git repo and everything is in DevOps. And I have also a local copy on my computer to make some updates. As you can see, the local copy points to points to the repo in the cloud. Like Marta said, we have installed the mesh environment using OSOC, the Oracle Service Operator for Kubernetes, that allows us to do everything with kubectl. And okay, let's go into that. So let me do like kubectl get namespaces. So we have this mesh running in its own namespace. And when we do the update, it will create a new namespace for it and delete the old one eventually. So we can see that the current mesh is running here. It's been running like 25 hours in this namespace. So let's see what's inside. In that namespace. So we have the home service v1 that Marta showed in the slide 1, and then we have the ingress, the load balancer ingress that allows access to that home page. So okay, then the page, the bootstrap page, is running behind the ingress here. So yeah, I think I have an automatic refresh. I can take that off. So yeah, so the page is here. It's a static page. All the values is static, like in the original page. And if you take a look at the traffic from Grafana, you can see that 100% of the traffic goes to that page. Okay, no magic there. Very simple. Then yeah, let's take a look at the project. So like I said, we have the DevOps project where the mesh has been and the application has been deployed, built and deployed. So in the local repository that I have a copy on my local disk, we have the files. And yeah, we can first maybe take a look at the meshify.yaml that shows the current setup for the traffic and everything. So all the components are described here. And behind the virtual deployment, we have the virtual service. And let me check. The traffic split is here. Sorry, this is not the right one. Yeah, sorry, I was in the wrong branch, because this is the branch that we're looking at here, the V1 first. The main branch contains the V2 actually. So yeah, so my apologies. So this is the correct YAML file that we've deployed the mesh and the application with. So we can see from here that the virtual service route table for the home service is like 100% traffic to the V1, because that's the only thing we have. And then we allow the traffic from using this policy, access policy, which is that we allow traffic from ingress gateway to home, and that's it. Very simple. Okay, so these are basically the config files, and then there's a lot more, but this is what I want to show here. And then we have the DevOps project where we have the mesh project or mesh service, mesh service instance, let's say. And the name of it is actually the same that we have the namespace for, to keep it like simple or easy to relate to. So when we create the mesh using kubectl, it will use the same name as the namespace we are using. So let's go into that. You can basically create the mesh in two ways, either from the Cloud UI or kubectl. So we chose the kubectl way, and basically just you can view the values from Cloud UI. So like we saw, there's this virtual service home, and then behind it there's a virtual deployment v1, and then there's the listener port 3000, and then we have the route table for the traffic routing, and that's basically yeah, very simple, 100% to that v1 because there are no alternatives. And then we can take a look at the yeah, there's the ingress and also the access policy I mentioned. So this access policy allows the traffic from the ingress gateway to the home service. Because the update takes a little bit, so let me kick off the change. So I'm gonna show the change, but first let me kick off that. So let's yeah. So I have the branch v2 here locally, and git push origin v2. That should trigger the build. And if I go back here to the code, we should have the v2 also here now. Okay, v2 is here. So what did I change? I basically changed. Well, first of all, I'm deploying now the price building and deploying the price microservice to OKE, and then adding some configurations on top of that. So Meshify app YAML has been changed. So now we can see that the virtual service route table contains also the v2 with traffic split 2080. Okay, very static traffic split. And then the access policies has been added so that we also, besides this ingress gateway to home, we allow traffic from price, from home to price. And then we also allow traffic from price to database, to like very simple configuration to any port the ATP uses. So, okay, so that has been changed. And the build job should be going if things are going well. So let's go to the build pipelines. It's very simple build. It's only one. So we are doing this immutable build. So we build everything. So it contains only one step here, and a lot of things are done with kubectl. So the build has already started. So it has like 5 steps to complete. We can take a look at these later, but it's going. So I'm gonna leave this, but one thing I wanna do first is I'm gonna let's see, kubectl get namespaces. So now we also have this new namespace for the new mesh. I'm gonna do kubectl get pods minus this new namespace. I'm gonna leave it. Meanwhile, it's building and doing a watch for that. So there's nothing there yet, but there's gonna be a lot of activity once the build gets going a little bit further. Okay, back to Marta. Oh yeah, actually, maybe there was one thing I wanted to show. Would that be okay?
Of course.
Yeah, because that's like a small interesting fact. Sorry, jumping. So I was, my intention was to show also this home.js, the source code for the microservice. So, this just shows how easy it is to call the price service from the home service to get the values.
You're not showing yet.
Oh, am I not? Okay. Oh, sorry. Oh boy. Okay. Yeah. So the home service source code. So I'm just showing this to show how easy it is to get or do calls between the services, the microservices in the mesh. So you can just use the name that you deploy the service with, and then you put the port obviously. And this will return the JSON first going database and getting the values, and then returning JSON from the price service to the home. But the call is very easy. So just use the name of the service, and that's it basically. Okay, that was it.
Perfect. Yeah, the code is easy, and also we saw the mesh is very easy. So it's both things. So maybe let's just to recap a little bit what are cloud native applications and what are microservices, because just because your application runs on the cloud, it doesn't mean that it's cloud native. The new applications are tending more to microservices rather than monoliths, and monoliths are the old applications, and sometimes they are kept, but sometimes they are also rewritten. And what are microservices? I'm sure most of you already know. It's this fine, granular service with business logic, and usually they're all loosely coupled, and they communicate via lightweight protocols. And why would this be helpful? So imagine you have this huge monolith, and you have to onboard a new team member. And this person needs to learn all the logic, because if you touch something here, you might break something here. Or if you need to deploy the new application, you need to stop the application server, deploy the new version, restart the application server. So this has to be done usually at night or on the weekend. So it's much, much easier if you just need to do a little tiny logic for the new member as well. You just need to learn one, and then one, and then one, and then another one. Also, fixing a bug. for example. It's much easier to just fix a tiny piece of code, to test that, and to deploy it. Also, if you need more scalability, more power, more performance for just a part of your application, not all of it, so much easier to scale. Imagine your typical online web page. You have different microservices there. You have your catalog where you can search for your products. Maybe you have some recommendations. That would be another microservice. Your shopping cart, of course, your store locator, all these different logics are microservices. And sometimes they communicate to each other. So the recommendations talks to the catalog service, the catalog service talks to the shopping cart service. What are developers using today as well? We're using the DevOps concept. It's not a tool, it's not a technology, it's a combination of practices. You could even say it's a philosophy, plus all the tools that help the team of developers and operations. That's why it's called DevOps. Usually there's no human intervention. So only a failed test would prevent the change to go into production. Like we saw here with Mika, he did the change and it triggers the whole automation. So automation is key in this process. Automate everything. And then you will see a continuous stream of improvements. Of course, automation takes a little while to implement, but the long-term benefits are so much better. And you can also you can afford to have a small error budget. So you're allowed to make mistakes because you can fix them very quickly. So innovation is also much, much faster. And what is a service mesh? Why would it help us here? Service mesh is a solution for managing the communication between individual microservices. We saw already that we defined how these microservices communicate between each other. Each microservice is a separate entity. It has its own business logic. And when we need to tell them how to talk to each other, we have to have the endpoint of one microservice to all others that they need to talk to him. So this is new information that you need to add as part of the application deployment code. Sometimes the communication inside the cluster is not secure. So this might not be okay for larger applications because they might have sensitive user data, like an online banking, for example. So you don't want that price service to talk to the outside world or to other services, like we showed here. Sometimes we need to implement some kind of retry logic mechanism. So you will have to add that also in the microservice. And many times you also need to retrieve some metrics to monitor how your service is doing, what HTTP errors, how many requests, what are their response times. So all this additional logic has to be added to the service. This is non-business logic. So your developers, they're not working on your actual logic. You're adding complexity and you're adding stuff for your developers. So what the service mesh does is to extract this logic and is moved to the sidecar application. And this sidecar application acts as a proxy. The cluster operators can configure it easily. And then the service mesh has this control plane that injects the sidecar proxy in each pod. Additionally, one of the most important features is traffic splitting. For example, when you want to do a canary deployment, usually you can't prove the absence of bugs. So what you would do is deploy a small part of your application, maybe 10%, 20% like we did, to test it out. And then 80% keeps the old version. And then you can also see how that's behaving. Service mesh is a pattern or a paradigm. Istio, for example, is one of open source implementation. And of course, in OCI, we have our own implementation in the managed PaaS service mesh, which is free. Okay, so what we said, the service mesh uses a sidecar model. The code that implements the network functionality is encapsulated into the network proxy. And this architecture relies on the traffic from the service and to the service to be redirected into the sidecar proxy. The application container sits along the sidecar. That's why it's called sidecar, in the same pod. So they all share the same network, same net space, and the same IP address. And that allows the containers to talk via localhost. Like we said, the sidecar is decoupled from the application code, and it was the traffic, the security, the connection management, and then you don't need to do any application code changes. So this way, your developers can focus on the real logic of the service, and operations can focus on this management. This additionally, it allows easy to scale up when you need to scale up and down one service, to update your services, to maintain, and it enables team autonomy. And of course, what we were saying, your developers will be more productive. Small example of the current service mesh implementation is based on the Envoy proxy implementation, and we have here Prometheus and Grafana. Prometheus is retrieving the metrics, and Grafana is used for to display them, and we will see that afterwards in the demo. And we showed earlier a little bit the functional architecture of the demo, how it works. This is the physical architecture. Like we said, we have a Kubernetes cluster with both services running. We have an autonomous database with Apex, the secrets in the vault, and the DevOps service triggering the pipeline to deploy the code. Yeah, and here we have the triangle. The three main components that we're using is the DevOps service, OKE, where microservices are running, and the OCI service mesh that controls the traffic, the security, the communication, everything around it. And let's see how the demo is going that we triggered earlier. Did the build finish?
Yeah, it did, Marta. So yeah, let's have a look at that. So I'm gonna do sharing. So this is where we left. We can see a lot of has happened on the kubectl. So the services get updated, some new services were created, and so forth. Meanwhile, you were speaking, I also took this out, and we can see that the old namespace is gone, and we have this new namespace only here in the kubectl. So this is where we are. So okay, let me do a clear. And yeah, on the cloud side, so our project, our build has completed. So we did this immutable setup or build, and it was completed. Took some time, so we can see the output here. This is steps went through, and we can see in the end the DNS was updated to the ingress IP address. So yeah, looking good. And then on the service mesh side, yeah, we got the new one, and we got the new services. So besides also the home, we have also the price service, and the home has new
version.
Virtual deployment. Yeah, virtual deployment home v2, and the root table got updated. So that's gonna be 80/20 as we saw being updated, and then we have the access policies updated. So sorry, yeah, so we got more policies there. So as opposite to only the ingress and home, we got home, price, and price to any external service, in this case our autonomous database. So that's looking good. So let's call the page. So let's do a refresh, so we can see that the page has been it is working. The values has been changed a little bit from the Git. So so you can see that now. Okay, this is static page, and this is the dynamic page. So the split is something like 80/20, and let's take a look at the load balancer. So so this is the Grafana, and the other one is the ingress. So let's take a look at this one. So and this was also recreated within the build. So yeah, last 5 minutes, and let's keep calling the page. So we can see that traffic is settling to 2080 as we keep calling the page. So the traffic here is here, so it's gonna settle that. And And we can call actually the admin from here. So that's the Apex application. So let's go sign in and you can update the prices. So these values came from JIT within the values that were on the development phase. So we can put like 20 here and 150 here, update, recall the page. So here we go. So it looks to be working. Yeah,
Awesome.
I think we're good. Yeah, thank you.
Great demo. Lots of stuff deployed in the build pipeline. So it's a very, very complex demo. So that was really great that it worked. Just as a couple of slides as a summary. Here's where we had the build pipeline. So you don't have to do always a full build and a full deploy. In this case, we did, so that you see the whole thing. You could just redeploy the microservices. And another option is to do it manually in the console. You want to change, for example, the traffic to 100%. So you don't need to redeploy the mesh. You just do kubectl. So there's many, many options. We went for the long one so that you see all the complexity and how easy it is to do it. Because the key that we want to show here is that you can automate so much. You can automate every deployment that you have. You don't need to do anything manually, but you can decide for whatever works for you best. And if you go to Mika's GitHub repo, you will see the build spec YAML file with all the specifications. This is more or less what it does, maybe in a different order. First, the microservices are built as Docker images. Then that image is pushed to the registry. It's deployed to a new namespace with the mesh name. Then the application is meshified and the mesh is created. And then at the end, we do Grafana. You can update the DNS with the new IP address, and then you can delete the old mesh. But you can delete the old mesh at the beginning. So whatever works for you best. Just check it out because it's a very complex and very, very nice example of how many things you can do. Small summary why we think the service mesh is really good for you. It's a free service. You will improve your operational efficiency. Your developers will be super happy and super productive. You will have end-to-end visibility on your service and the communication. You can connect them dynamically, we saw with the access policy, and then you can secure the workload. So not every service is exposed to the outside world or to the inside. Thanks a lot.
So if no further questions, I would like to thank you all for attending this call. I would like to thank you, Marta and Mika, for presenting this session. And of course, we are happy to see you within upcoming cloud coaching sessions. Thank you and have a great day. Bye-bye.
Thank you.
Bye-bye.
Bye-bye.